All right, in this video, we're going to talk about factoring an expression by pulling out a common factor. All right, so when we factor by pulling out a common factor, basically what we're doing is we're using the distributive property in reverse. Right? Remember, the distributive property is when I have something outside of a parentheses and I distribute it, I multiply that into the parentheses. But what we're doing here is kind of taking the result of that and then writing, well, what would this look like before I use the distributive property? What can I pull out of this, and then what do I put in parentheses so that when I distributed it, I end up with what I have out here. Right, so that's basically what we're doing here, is just the distributive property backwards. Now, the way we do that is, for this first example here, 5a squared minus 25a. Right, so when I'm looking for factoring, or when I'm factoring, no matter what type of factoring method I use, the first thing I should always look for is a common factor. Right? Because if your terms have a common factor, then the other factoring methods that we'll get into later get a little bit easier if you can pull out that common factor first. All right, so I look for, well, what do these two terms have in common, the 5a squared and the 25a? All right, and when we have numbers and variables, we have to look at all of those things. So first look at the numbers. I have a 5 and a 25. Do those two have any common factors? They do, right? They both have a factor of 5. Right, so I'm going to just go on the side here, and this is not something you have to do when you do these problems, but I'm just going to write down the common factor. So my 5 and my 25 have a common factor of 5. All right, then I look at my variables, my a squared and my a. Well, those have a common factor of a. Right, remember, a squared is a times a, right? It's two of those a's multiplied together. This is just one of those a's here, so what they have in common is 1a. Right, so my common factor here is going to be 5a, right? That's what these two both have in common. All right, so then when but basically what I'm going to do now, once I figure out what that common factor is, I factor that out, is what we call it. Right, so I write that 5a outside of my parentheses, and then I got to figure out, well, what do I put in this parentheses that when I distribute that 5a back into it, it's going to give me 5a squared minus 25a. Right, and some people can look at that and just say, "Oh, I know exactly what it is, and let me plug that in there." If you're not sure, think of it like this. Think about, well, I'm dividing both of these things up here by this common factor, this 5a. Right, so if I do 5a squared and I divide it by 5a, right, the 5's would cancel out, and the a squared over the a is just a. Right, remember, with the rules of exponents, a squared over a. This is a to the first power. I subtract the exponents. 2 minus 1 gives me an a to the first power. Right? And if I do the same thing here, I have that minus in the middle. And then if I do 25a over 5a, well, here those a's are going to cancel out, right? Because they're both an a to the first power. And if I have 25 divided by 5, that's going to give me 5. Right? So I get 5a times parentheses a minus 5. Right? So I have what we call, I've done, factoring out a common factor. Now, to double check your factoring work, all you have to do is multiply it back together. If I distribute this 5a into the parentheses, 5a times a, right, that a times a gives me that 5a squared. And if I do 5a times the minus 5, that's going to give me the minus 25a. All right, so I double checked it. It works out. I factored out my common factor. Right, again, it's doing that distributive property backwards. Right? And to check it, we just use the distributive property to double check. Right? Remember, what factoring is? Factoring is taking an expression that involves addition or subtraction and turning it into an expression that involves multiplication. Right? 5a times a minus 5. This subtraction expression is now written as a multiplication expression. Right? The 5a is multiplying the a minus 5. Right? Which, factoring is a really important tool that will come up a lot as you go through algebra and precalculus and calculus. It comes up all the time in a bunch of different types of problems where being able to factor something and being able to create that multiplication is important to be able to use other rules that you'll learn along the way. All right, so we factored out our common factor there. It's 5a times a minus 5. All right, so that's just one way to approach a problem like this. Another way, and depending on how good you are with numbers and stuff like that, you can just look, well, 5a squared minus 25a, well, they both have a 5, they both have an a. Let me write the 5a here. And then if I do 5a times a, that's 5a squared. If I do 5a times minus 5, that's minus 25a. You might be able to do that just by thinking about it and not having to write down all that extra stuff, which if you can, good for you, and just go ahead and do it. If you can't, these are some extra things you can do to kind of help you figure out what that, or how to do this. Right, another thing you could do is, like, for the 5a squared, like, you can actually factor that. That's 5 times a, right? the 25a, well, 25 is 5 times a, right? And then what do they have in common? Well, they both have a 5, and they both have an a, right? So I pull out that 5a as my common factor, and then what's left is the a and the minus 5, and that's what goes into the parentheses, right? So that's another way you can maybe set that up and try to figure it out, is by actually writing out all the factors and just seeing what they have in common. Whatever matches up is what goes in front. Whatever's left behind is what goes in the parentheses. That's actually a pretty convenient way to do that. I just kind of thought about that now, but it works pretty well. All right, so let's actually try that method on this one here. All right, so I have 3a to the fourth b squared m minus 75 a to the third b m to the fourth. Right, so now it's similar to the one we just did, but now we've got extra variables here that we have to deal with. All right, great. So let's deal with that. All right, so the 3, can I factor the 3? I can't, right? 3 is just 3 times 1. So let me write the 3 here. The a to the fourth, that's 4 a's multiplied together. So let me write out the 4 a's. The b squared, right, that's 2 b's multiplied together. The m, well, that's just one single m. So there we go. All right, so that's 3a to the fourth b squared m. That's what that is, right? The 75, well, I have a 3 here, so can I write 75 as, you know, a 3 times something else? I can, right? 75 is 3 times 25. So it's 3 times 25 times a to the third power. So that's 3 a's times a b, and then times m to the fourth power. So that's times 4 m's, right? So that's kind of writing all that out. And again, this is one way to approach this problem. And then we look at, well, what do these have in common? Well, they both have a 3, right? So the 3 is going to be part of my common factor. They both have 3 a's, right? This one has 3 a's, this one has 4, right? So when you have the same variables raised to a power, your common factor is going to be the variable raised to the lowest power, right? This was an a to the fourth, this was an a to the third. My common factor is going to be an a to the third, right? As we can see here, this one has 3 a's, this one has at least 3 a's, and there's that one left behind. Right, so I can pull out that a to the third power because that's what they have in common. This one has 2 b's, this one has just 1 b, right? So I can pull out then one single b, right? Because they both have at least 1 b in common. This one has 1 m, so I can pull out that 1 m and I can pull out one of those m's. So there's my common factor. It's going to be 3a to the third b m, right? So again, if I factor it all out and I write out all the variables and everything, they both have a 3, they both have 3 a's, they both have 1 b, they both have 1 m. Now, what's left behind after I do that? Well, I have an a and a b from that first term, and that's all that's left behind, right? Everything else got pulled out. And then in the second term, I have a minus 25, and then I have no more a's, no more b's, but I have 3 m's, so that's going to be an m to the third power. Right, and that will be my factoring. And notice what's left in the parentheses here doesn't have anything left in common, right? The a and the b have nothing in common with the 25 m to the third, right? If you notice that they have nothing in common, that means you took out the greatest common factor and you're in good shape there, right? Same up here. The a and the minus 5 don't have anything in common. That's a good sign. All right, so we have, find our common factor here, which is the 3a to the third b m. And then what was left behind. Hopefully that makes sense the way I did that by writing out every single factor and then just pretty much putting a box around what they had in common. Whatever has a box around it is the common factor that you pull out. And then when you make your parentheses, whatever doesn't have the box around it, in this case the a, b is my first term, the 25 and the m to the third power is my second term. All right. And once again, to double check this, if you distribute this, remember, factoring out a common factor is just the distributive property backwards. So if I distribute this, if I do 3a to the third bm and multiply it times ab, well, that's going to give me a 3, a to the fourth power, a b squared, and an m to the first. So that matches my first term. If I distribute it to this second thing here, the 3 times the minus 25 is going to be minus 75. The a to the third is a to the third. The b is the b. The m times the m to the third is the m to the fourth. And it all checks out, so I know that I have the correct answer. Right, when you're factoring, especially if you're not that confident with factoring as you're first learning it or first getting used to it, just doing the multiplication at the end to double check, you got it right or you got it wrong. And if you got it wrong, you can go back and try to fix it. All right, so that's factoring by pulling out a common factor. again, one of the important methods that we have for factoring. And in some more videos that I'm going to make soon, I'll do some of the other methods of factoring that you can use. So make sure you check those out as well.